See, the boy is lifting a dumbbell. See, 5 सेकेंड में वो तुल रहा है जो है. हाउ मेनी टाइम्स ही कैन लिफ्ट द डम्बल. धीरे धीरे जर से करो, जल्दी करो, लेकिन उसको नहीं हो रहा है. जल्दी करो लेकिन नहीं हो रहा है. एक है, एक एग्जाम्पल है. ये क्या कर रहा है? ओके. 1 2 3 4 5 6 7 8 9. ओके. ऐसे 10 11 12 ऐसे जल्दी हो रहा है. क्यों हो रहा है? वो नहीं पढ़ रहा है. I am able to do lift in one second, but the very boy could not. What is the meaning? So I will explain here out there. So, yes, I am your favorite Shankar sir. I am here to start and welcome you in my channel Study Hub. Today I will discuss about the work for energy, the last part. Probably I will try to complete in 1/3. And देखा, am I a bodybuilder? Most probably all of you already comment already आ गया. Sir, bodybuilder, but I am not bodybuilder. I am not bodybuilder. I am trying potential energy. What is potential energy and how it differs, how it depends? Okay, see, this is the surface. From the surface, this is out there. So in this case, this has no energy. Just it is attached to the surface. If I pick it up and छोड़ दूँ, ये जो गिर रहा है यहाँ पर, इस पे तो ज़्यादा फोर्स नहीं किया. If I ऐसे, the height is increasing. अगेन छोड़ दो, उससे पहले से ज़्यादा वो स्ट्राइक कर रहा है. हाइट अगेन आई विल इंक्रीजिंग द हाइट. देन इसका छोड़ दो तो व्हाट विल द साउंड इज हाई. दैट मीन्स इट गिव्स द हाई स्पीड एंड हाई एनर्जी. व्हाई? व्हाट इज द रीजन? आई विल डिस्क्राइब इट. ओके, सी, सपोज दिस इज अ स्टोन. If I lift a thing, say stone, if I lift from the surface, from the ground, and place it on the top of that is the table. Some work is done on the stone. If this stone fall down from the top of the table and hits another thing laying on the ground, suppose there is another thing, it will hit and it will displace the second thing which is under the surface. It will displace the position. Why? This simple activity proves that a falling stone or falling body has the potential to do work. The potential to do work. Now question comes, from where this potential energy come in the stone? When you lift the stone, this is the stone, from the ground, the work done by you, to raise it is stored it as energy. Okay, this stored energy is known as potential energy. This stored energy is known as potential energy. So what is the definition? The energy possessed by an object. The energy possessed by an object by virtue of its position, by virtue of its shape or configuration is known as potential energy. Clear? The energy possessed by an object by virtue of its position, shape or configuration is known as potential energy. Clear? Now, the example of potential energy I am giving, suppose the water stored in a dam. In your house also there is the water tank are there. If you done a hole in the side wall of the reservoir, what will happen? The water comes out. Why? That is stored in the water. So water is, what is? energy is there. So it comes out of the water. Coiled ring, coiled spring of watch, it is example of the potential energy. And also the stone lying on the top of the hill, it is also the example of potential energy. Okay, so next come. How to?
This object out there, this is M, this is M, this is out there, out here, that mass is M, this is the force, okay, this is the force, and this is also M, this is position A, this position is B, okay, now, see out there, okay.
So how to find out the potential of an object at a certain height? Certain height. Out here, it's out there. So from here, it has possessed the potential energy by position. So what is how you will determine the potential energy of an object at height? Okay. So suppose the object M having mass M, it is in the ground level A position. I am applying the force out there. So and after certain height H, it will out there M, and the position out there is B, and this is the certain height H. Always what you know, what is mg? Weight. Every object is attracted by the earth. So weight of the object, what you know? Weight of the object, W equals to m into g. We know weight equals to mg. So to move the object upwards from A to B, a distance through h is, and a force applied. If this is the force applied, I have to apply the force, okay, which in upwards. So F equals to mg, F equals to W, so F equals to, and so here what we write, F equals to mg. We know work done by the force, W equals to what? F into S. So in that case, W equals to what? F into S means H. Work done. This is the work done. Equals work done. W equals to F into H. We know. Where? What is F? F equals to mg. So if we put the value out here, mg H, here F equals to m into g. So W equals to mgh, and this mgh, what? That is the potential energy. What you know? Potential energy. Potential energy. We know potential energy means work. What you know? Potential energy means work. Work done, potential energy. That means EP equals to mgh. EP, that is the potential energy equals to mgh. So this equation is true. This is the potential energy equals to mgh. Very important equation. And remember, this equation is true only if velocity is constant. Okay, no change in kinetic energy. And if g is constant, that is near Earth's surface. In that case, it is true. Okay, so one thing you have to remember, suppose potential energy, it is the path length. Potential energy, that is EP, is very important. EP is path independent. What does it mean? EP is path independent. What does it mean? Suppose, see out here, this is clear. Potential energy equals to mgh, clear? Okay, this is the equation, mg, potential energy, mgh, kinetic energy, half mv square, clear. So what I am telling out here, see out here, okay, this is the thing. Suppose this is the body out here, I am lifting it out here, A to B, clear, out here. If this object, if this object out here, if it out here, then goes out here as a, okay, then again goes out here, clear, then again out here, then again out here, position, the A to B, the path. So path lengths path length from A to B and from path length from A to B is different. Path length is different. But height are same. But the height, the object is from A to B, from A to B, it is same. That's why AP is path independent. It does not in which direction it is going. It depends how long. What is the total ultimate length of the path? Path length, that is the height of the path. That is path. AP is path independent. Clear? Next. Now I will discuss about the law of conservation of energy and also to prove in case of free falling body. Okay. So what is law of conservation of energy? Very important. Energy can only be converted from one form to another forms. Energy can only be converted from one form to another form. It can neither be created nor destroyed. Total energy in this universe remain constant. Okay? Clear? Total energy in this universe remains constant. It can neither be created nor be destroyed. This is the law of conservation of energy. Very important. So, law of conservation of energy in case of freely falling body. How you prove? It is in case of free fall of a body which is free fall you have learned, without any friction, without any disturbance, free fall. In that case, how law of conservation is maintained, how it is maintained. So I am explaining out here. See, okay, see, suppose this is in the ground, a body is there in position this. After some time, it is in this position, and after some time, this is out here in different distance out there. Okay, okay. This is ground level. Okay, this is ground level. Okay, so this is total height. Suppose this height be h. This height be, suppose this height be h. Okay, this height be h out there. Suppose this from this to this is position A, this is position B, this is position C. Okay, and suppose this is x. Okay, this is x. So what will be this distance between this and B to C? Tell me what? Yes, h minus x. Bah, Sanatan good boy hai. Srijito good boy hai. So this is x, this distance. This is x and this is h minus x. Clear? So you have to maintain it. This to h minus x, this is h. So in this position C, B, A, suppose a body of mass m. Suppose a body of mass m. Clear? This body of mass m, it has lifted to position A, that is the height of h. So height कितना दूर? h. Centimeter unit you will give. That is the from ground level to A position, इसका height होगा h. h height equals to h. Okay, at A position. Clear? Now, and at A, suppose at A. Now at A, the velocity will be what? it is at rest. So velocity at A, velocity V equals to 0, that is the rest position, we know. So from here, when it comes downwards, so I will find out the total energy, that is kinetic energy and potential energy at different position A and B and C. So at position A, see, watch, at position A, तो लिखिए at, I am not writing all these things, at A में इसका kinetic energy, potential energy कितना होगा? तो A में इसका potential energy of the body, the mass into G into height, that is potential energy will be mgh. Clear? It is clear? Potential energy, I have lifted the body of mass m at height h and g, of course. So potential energy will be mgh. Clear? But out here kinetic energy half mv square, out here kinetic energy equals to half mv square, but out here v equals to की 0. What is the velocity? कितना होगा? 0. velocity 0 है ना. So if it is 0, so total value will be 0. So kinetic energy will be 0. So total energy at A, total energy equals to potential energy plus kinetic energy, that is mgh plus 0, mgh plus 0. ठीक है ना? पोटेंशियल एनर्जी mgh है, काइनेटिक एनर्जी 0 है, सो इट विल बी mgh. ये है एक नंबर. So many numbers are there, I am not giving, main number is I am giving. So at A, total energy is mgh. Now at position B, but what है मिठुन? ओके. एट बी, अभिनंदन, ठीक है. तो एट पोजीशन एट बी में, तो बी इतना हाइट कितना है, इसका एज कितना हुआ है, एच माइनस एक्स. तो इसमें पोटेंशियल एनर्जी क्या होगा बोलो? mgh. इसका एज का मतलब क्या है? एच माइनस एक्स, mgh माइनस एक्स. इसका काइनेटिक एनर्जी हाफ mv स्क्वायर. You have find out the v out at 0, but what is the v out here? You have to find out v, velocity at b, velocity of the object at b. Okay, b position में velocity कितना है, you have to find out. You have to apply the formula v square minus u square, b square minus u square equals to twice as. क्लियर? यहाँ पर twice gs by as. तो एट यहाँ से यहाँ तक. इन दैट केस at position B, in that case what you will find out? V equals to what? You have to find out. U square equals to ki what? U equals to rest. U equals to, from the U here, U equals to 0. So out here 0, the V square equals to 2gs. Clear? V square 2gs. So out here find the value. This V square value we have to replace. हाफ m, चले हाफ इंटू m इंटू v स्क्वायर का मतलब क्या होगा? 2gs. 2 तो कट गया, mgs. क्लियर? mgs, that is mgs means x. क्लियर? to mgx, এখানে x, this is the x. यहाँ तक कितना डिस्टेंस है? x. so equals to mgx. क्लियर? दिस इज x. यहाँ तक डिस्टेंस हाइट mgx. सो पोटेंशियल एनर्जी प्लस काइनेटिक एनर्जी क्यों होगा? what will be the add karo potential energy at B. If you add it, mgh, this will be mgh minus mgx. This plus this, that means mgx cut gaya. This will be, so potential energy plus kinetic energy equals to mgh. This is also at B. Now at C, potential energy at B, mgh. This is 2. Clear hua? This is x. Here u 0. You have to find out half mv square. Half mv square you have to find out. Okay. Next.
So at C you have to find out what will be the potential energy and kinetic energy and the sum of the potential energy and kinetic energy you have to find out. Just like A and B, you have to find out. Okay.
So now at C, at position C में कितना होगा? C देखो position C में, this is the out here, that is the H equals to 0. Clear? That means kinetic potential, first potential energy mgh. Clear? Out here, this is the surface, so there is no H. So in that case, H equals to 0. So it will, total value will be 0. Potential energy will be 0. Kinetic energy, same thing. What is the formula? Half m v square. So you have to find out the value of v square. V. What is the v? You have to find out. The v equals to what? Let it down. V square minus u square, 2as. V square minus u square equals to 2as. Clear? Out here, what is the value of from here? That is v equals to 0. Yes, और u equals to at a में जो होगा इसमें अलग होगा, तो a equals to g, out here, और s equals to यहाँ से यहाँ तक h, यहाँ से यहाँ तक h, यहाँ से यहाँ तक c, that is the h. A equals to g, that is v square equals to 2gh. Clear? 2gh. So out here, half m 2gh, half कट गया, equals to mgh. So kinetic energy equals to mgh. So sum of the potential and kinetic energy, that is P plus E Ke, 0 plus mgh equals to mgh. Third, so what we learn out here from at position A, at position B, at position C, what we got, that is the sum of the potential energy and kinetic energy always remain same. This law of conservation of energy has been conserved. Okay, it is proved. Law of conservation of energy. Clear?
Conservation has been verified. The law of conservation verified. Clear? Now I will discuss about power.
स्टार्ट पावर, ए क्या है, हम क्या बोलना, पावर स्टार्ट करना है ना, तो स्टार्ट कर दिया. थोड़ा और एग्जाम्पल है किसके लिए ना, कंजर्वेशन ऑफ एनर्जी. तो क्यों भूल हो गया, ये थोड़ा बुढ़ापन आ गया क्या, मियाँ हमें बुढ़ा हो गया क्या, हो सकता है. सो लेट स्टार्ट. दिस इज वेरी इंपॉर्टेंट टू क्लियर द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. ये तो इंजन देखो, ये बॉल है, ए पोजीशन में है, बी पोजीशन में, सी पोजीशन, डी में, ई में. ये थोड़ा सा आता है फॉलिंग बॉडी है. इट इज अ रेस्ट एंड इट इज फॉलिंग बॉडी एंड जस्ट इट हैज टच बिफोर द ground. Okay, the position. What is C? Potential energy at A and kinetic energy at A and total energy of the ball. If you look in this chart, what will you see? The sum of the potential energy and kinetic energy will be fixed, will be same. Here what you see, out here, potential energy at P, it is at rest. So potential energy is 20 joules at, and kinetic energy 0. So sum is 0. At B, potential energy 15, it is 5. Addition 20, potential C 10, 10 सेम होगा. इन द मिडिल पोजिशन सेम, हाइट सेम. इससे यहाँ पर हाइट, इससे यहाँ पर हाइट सेम होगा. सो दोनों सेम होगा. सो 20 जूल. द सम ऑफ द काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी इज सेम. What is true? What we see out here, last position E, the kinetic and potential energy 0 and kinetic energy maximum 20. Out here potential energy 20, kinetic energy 0. What is see out here? Just the potential energy as the body ball going to fall, potential energy is being decreased. Potential energy is being decreased. And same way, kinetic energy, what? Potential energy 20, 15, 10 and kinetic energy increased. Okay, potential energy decreased, kinetic energy increased. In this way, sum of potential and kinetic energy are same. The sum all are in case same. So it is already verified. It is very good examples. In case also pendulums also. You also read in your book. So next start the power. What is power? What is you earlier at the very beginning? A little boy. Who is Srijit? He is lifting the dumbbell. He has no power. ऐसे चल रहा है. I am. Okay. In 1 second, 1 time, 2 times, 3 times. Why? Because I have this energy and power. What is power? Work done by time taken. He is taking the time more. I am taking the time less. I am dumbbell man. Because work done by time taken equals to power. Work done means energy consumed. So energy consumed by time. So work done W by T. P equals to W by T and P equals to E by T. W का यूनिट क्या है? जूल. T का सेकेंड, जूल पर सेकेंड, that is watt. This is a unit of power. Clear? So more the work done in time is less, has more power. Work done less, time taken more, power is less. Okay. So let's see the conversion. The 1 kilowatt hour 1000 watts, that is 3.6 10 to the 6 joules also. Megawatt 10 to the 6 watts. 1 horsepower. Another units of the power, horsepower, it is 746 watt or 0.75 kilowatts. So note it down, and here I draw my ends. Good night. Goodbye.